Welcome to Looking at Surface Area. Now, in this video, we're going to be really focusing on what surface area means and how we can establish values of surface area. We're still looking at a type of area though, we're just looking at the area all around an object, okay? So because we're still looking at area, we're still using our units squared as we did in area. Now, we're now though thinking of 3D shapes, okay? So our object has different faces, and it's the area of those faces that we're going to be looking at. So we looked at area, and in area we said, like, if we was looking at this paddock here, the area is all of what is inside the fence. The perimeter was the actual fence line, and the area what was inside. We looked at how we could find the area of rectangles, which was our length times our width. We looked at how we can find the area of a triangle, and we said it was half times the base times the height, and the reason we're doing half is because if we just did base times height, we'd find the area of the whole rectangle, whereas a triangle is half a rectangle. We looked at our parallelograms, and we said if we just cut the triangle off one end and put it onto the other, we had a rectangle, so it became base times height. We looked at our rhombi and kites, and we said we was going to be multiplying the longest height distance as such by the longest width distance, and then multiplying them by half. So multiplying them together and by half. And we said that's because if you do the longest height distance multiplied by the longest width distance, you're making that full rectangular or square shape, whereas it's actually half. Then we looked at the area of composite shapes, and we said we'd have to cut our shapes up into individual shapes, find the area of those, and then add them together. And that's really similar to what we're doing with surface area. We looked at the area of a circle, and we said that we find that out using the calculation pi r squared, but we actually looked further into what that meant, and we dissected that circle out into sectors and then put it into a kind of parallelogram shape. This is just a summary of all of the different formulas for each shape. So we now move on to surface area, and the reason we had to cover area again was because you will need to find the area of different shapes to find the overall surface area. So why look at surface area? Well, for example, if you wanted to paint the outside of this house, you need to know how much surface area there is that needs painting to know how much paint to buy. You don't just go along to Bunnings and buy a random amount of tins of paint, because you're either only going to half paint your house because you run out, then you have to go to Bunnings again, or you're going to buy way too much. And if you have specially made paint, Bunnings do not like having it returned. If you've been out into country Australia and you've seen the silo art, the artists that paint these silos need to know the surface area of the silos, again, to know how much paint to get for them, but also when they do their initial plans on paper, they need to work out the curves and the surface area to work out the scale of enlarging their diagrams and their drawings. Okay, so we need to know a bit about 3D shapes, okay, and here we've got a diagram, a chart showing us a whole range of shapes and their 3D names. Now throughout this unit I'm going to talk about different shapes, and this just, you can refer back to this slide to see what I'm actually talking about if you're confused. But these are the names of different shapes in 3D. So where we had a square in 2D, we now have a cube in 3D. Where we had a rectangle in 2D, we now have a rectangular prism in 3D. Now when we're talking surface area, we are talking 3D shapes, okay? Okay, so what we need to know about is we need to know about these things called the nets of shapes. Now we're not talking about nets like me running off catching my butterfly there. we're talking about our 3D shape opened up into 2D. Okay, so the net, if you look here at the cube, we've got a cube, but if we can open that up, okay, we get the net, right? The net of the shape. And you've got some other nets there for some different shapes as well. All right, so a cube has 11 different nets, okay, and here they are. This was one of my challenges as a year 6 going into year 7 over the summer holidays. I had to draw every net of a cube and work out how many there are. Nowadays you can just Google how many nets of a cube and it just comes up. But all of these, if you folded them up along the lines, you'd make a cube. Okay, they're just different ways you can fold them up and make the cube, but they're called nets. Now the reason that's important, if you find the area of one net, of one cube, one square there, sorry, and multiply that by 1, 2, 3, 4, 5, 6, that times 6, that will tell you how many, what your surface area of your cube is. Here we have the net of a rectangular prism, okay, and for this we would find the area of that side there, and those sides are the same, okay, so whatever the area that is, we've got 2 of them, so times that by 2, and then to find the area of all these, you could find one rectangle and then times it by 4, or you can go, well, we know the blue lengths are 5, so we say that 5 each, so that's 10, that's 6, that's 16, and that's 6, that's 22, and we could go 22 times 10 because we've made that into one giant rectangle there. Okay, and once we've done that, we've found the surface area, so we've found the area of all of those sides. Okay, a cylinder. So cylinders, these are fascinating, and this is part of what, if you was doing that silo art, you'd need to know how to find the surface area of cylinders. Okay, so to find the surface area of a cylinder, you need the area of the top. Okay, so that's 2 pi r is our circumference. Okay, now how do we find the area here? Well, it's 2 pi r squared, isn't it? So we'd find the area 2 pi r squared, but this 2 pi r, which is our circumference, that is how long our side is. So imagine you've taken this label off this green bins thing, okay, and that is how long that label is, that 2 pi r. So our circumference, which goes right round there, we've just unwound that label, so that the length is the same as the 2 pi r. And then we have the height, or we might call that the width. So we need to find the area of the top, times that by 2. Okay, so that would be the top and the bottom, and then we find the area of this side, or the label as such. Our triangular prism, okay, here we are. So we open that up into its net, and we'd find the area of these 2 triangles plus the long rectangle through the middle. Here where they've worked it out, they've found the triangles there, but they've found it out by finding the area of each individual rectangle there. And that's fine, you can do it either way. Okay, so again, another triangular prism here. We're just showing it there with the individual rectangles and the 2 triangles on the side. Okay, we've got one here which is showing that full working out. So they've found the actual area of this rectangle in the middle, and then they've done the 2 triangles either side. And then they've said the total surface area and worked that all out. And here they've just done it in a different way. They've found out individually each area, and then the total surface area is there. Just a reminder, actually I think it's the first time I've said it, TSA, total surface area. Okay, now we move on to some trickier ones. Look at this. This is the net of a cone. Now in year 8 we won't find out the surface area of a cone, but hey, you can, if you're interested, have a Google how to find the surface area of a cone. And then there's spheres. Now spheres are getting really complicated. Again, we don't do this in this course, but there's different ways that you can find out the surface area of a sphere. If you're interested, have a look on Google. Okay, so our key terms in this area, in this unit of surface area. Obviously, surface area is a key term. Prism, so you're thinking rectangular prisms, triangular prisms, okay? So they're those 3D shapes. Net, so that's that shape opened up. Total surface area. And that is all from this video. Now time for some practice.